Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius Podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy in my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out. And I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids, on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition, or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on current initiatives. And now, to our guest.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Kris Verburgh. He's the co-founder of NOVOS. He's a venture partner at Longevity Vision Fund. And we're going to talk about current developments in biotech that also intersect with anti-aging or understanding aging. Kris has a good command of what's the latest and greatest in biotech. So thank you for coming, Kris.
My pleasure. Thank you.
Tell me a bit about your history. How did you get interested in biotech?
Yeah, well, since a young age, I've been always fascinated by the big questions in life, like where does the universe come from, and is there an edge of the universe, or what is life, and why do we have to die? And yeah, I think why we have to die is one of the most significant philosophical questions we can ask ourselves. Why does aging even happen? Because actually it was a big riddle for a long time for biologists to find out why aging actually exists. So it's not simple wearing down of organisms or tissues. It's much more complicated. So I've always been interested in the big questions, and aging and death are very big questions in that matter. Also, when I studied medicine, I quickly realized that the best way to keep people healthy for the longest time possible is by going at the root cause of their diseases, of most diseases that afflict people, like heart disease, cancer, Alzheimer's disease. And the root cause of these diseases is aging itself. So let's say my philosophical mindset and critical mindset and thinking about, I love to think about interesting questions, and also the complexity of aging, and then realizing that most diseases are caused by aging are a few reasons why I got interested in aging and biotech. And also I love biotech because it's such a super fascinating field, in the sense we see so many new developments happening, and it's applied science to make people healthier and live longer. So I think we are also at the beginning of a new biotech revolution in that regard. So these are a few reasons why I'm so interested in biotech and aging.
Well, very good. So what are some of the new technologies that you think hold a lot of promise to help fight various diseases and address aging?
Yeah, there are many. So where to start? Like I said, we are at the beginning of a new biotech age, I believe. So in the last few years, we've seen the development and discovery of all kinds of new technologies that were unfathomable 10 years ago. So one obvious, let's say, new breakthrough is gene editing, like CRISPR-Cas9 and other Cas proteins that can substantially reduce the cost and improve accuracy of editing genes. And that's very interesting. The Nobel Prize was recently awarded for gene editing, which will enable us to much better and cheaper and faster and more accurately treat genetic diseases. So that's one. Actually, some people believe that we are at for the first time in human history, we will be able to, let's say, take our own genetic destiny into our own hands. Because if you wanted to introduce a new trait in people, normally it would take thousands and thousands of years, but now you can do it in one day. So normally it's human evolution happened through natural selection, which is a very long-winded process. Like I said, it can take many thousands of years to introduce a new trait into our species, but now you can do it in a day. Actually, you can almost do it in your kitchen because one big breakthrough of these new developments is that you don't need $1 million lab anymore to change a gene. You can now do it for about $100 in your own kitchen if you want to, given the ease of the process. So that's one interesting development. Another one is epigenetic treatments. So the epigenome determines which genes are active and not. And it's actually, you can switch on or switch off genes to epigenetic drugs. So you don't have to cut into the genome like CRISPR-Cas does. And that's also a very interesting approach, especially for aging, because we see probably one of the most important reasons why we age is epigenetic dysregulation. So some genes are switched on that should be switched off during aging, like pro-tumor genes, oncogenes. Some genes that should be switched on or switched off during aging, like maintenance and housekeeping genes. This is perhaps one of the reasons why we age, epigenetic dysregulation. So epigenetic drugs are very interesting. Of course, transcriptomic drugs, which is a bit like epigenetic drugs, they can also regulate gene activity. So then we have other interesting developments like AI for drug discovery and many other applications in the medical field, like diagnosing or determine your accuracy of dying within the next 5 years with up to 70% accuracy according to some algorithms, through organoids where you can grow small organs in the lab, through chimeric animals or where you can grow human organs in animals to solve problems with donors and donor organs. You have bioprinting where you actually can print tissue. So we have seen also some breakthroughs happening there recently. Immunotherapy, using the immune system or inducing the immune system to target cancer. Optogenetics, where you use light to switch on or off specific genes. So these are just a few examples of all kinds of fascinating new developments in the biotech field that will help us to live longer and healthier lives. That will also help us to slow down and even reverse aging, as we see in some studies.
So which of these technologies has the most or any clinical applications? Which one can people experience nowadays, possibly?
So the best technologies to address aging or improve health in general?
Let's go for one of each. Which ones do you see that are the most mature so far, that are actually in use?
Yeah, well, gene editing is becoming very mature in the sense we have some clinical trials going on. So this is based on the CRISPR-Cas technology, where these are like small molecular scissors that can cut out genes or introduce genes or let's say genetic sequences. So I think the gene editing field is moving quickly. Of course, when we talk about gene editing within the field, we also see fast developments. The first discoveries were made with CRISPR-Cas9 proteins. But the problem with these proteins is that CRISPR-Cas9 is good in deleting specific genetic sequences, so knocking out or disabling genes, but it's much worse at introducing gene sequences into the genome. So it can cut out or disable genes, but if you want to introduce genetic sequences into the genome, that's more difficult with these first generation CRISPR-Cas technologies. But then we have seen more accurate ways to modify the genome, like base editors, where you just change one small aspect of the DNA. And then we also saw prime editing about a little bit more than a year or so ago, where that technology enables actually to much better introduce genetic sequences into the genome, because you connect the CRISPR-Cas9 machinery with a reverse transcriptase enzyme that can introduce or reverse transcribe sequences into the genome. And that's very interesting. But then you even have like sort of third generation gene editing that's currently in development, where you use transposon-based technologies. Transposons are little sequences in our DNA actually that jump around. They are called jumping genes. You have DNA transposons and RNA transposons. And actually, when we age, you have all these sequences of DNA jumping around in our genome, which is actually not good because some of these, let's say, genetic sequences, they make copies of themselves and they insert themselves haphazardly or randomly into our genome. So they make copies that way. The insertion into the genome can actually, create genetic instability and so on, and can accelerate aging. But transposons are, let's say, nature's way to introduce genetic sequences into the genome, and you can harness that technology. So some companies and scientists are learning from transposons to much better introduce large swaths of genetic sequences into the genome, which could be actually very interesting compared to first generation gene editing, where, as I told, it was very difficult to introduce even small sequences into the genome. But with transposon technology, you could introduce whole genes or even multiple genes into the genome, which could be very interesting. So that's for gene editing. I think another interesting progress is epigenetic therapies. So we're learning more and more that the epigenome is very important. Some scientists say more important than the genome. It's difficult to make that comparison, but we do know that, for example, you have like specific worms that live in your backyard. They have also 20,000 genes, just like us. But we are, of course, much more complex compared to a worm, and that's mainly due to the epigenome that really fine-tunes which genes are active and how active they actually are. We also see companies focusing on this epigenetic reprogramming, which actually in studies we have seen can reverse aging, at least partially. So if you epigenetically reprogram old mice, you make them younger again. So these old mice, they have their gray fur is shiny black again. These old mice are much more active again. Their organs regenerate better. They are cognitively better performing. You just can see with your naked eye that these old mice look young again. And that's through epigenetic reprogramming. So that's also a very interesting area.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now, back to the show.
Again, clinically, it sounds like CRISPR-Cas9 may be the most furthest along. I had a question about epigenetic modification. Are we able to, it's not really sequencing, but are we able to look at the epigenetic marks someone has? Is there a test that we can do, and how would it work?
Yeah, definitely. You can do an epigenetic test to determine your biological age. I think that's a very interesting application of looking at the genome for health purposes. This is called epigenetic clocks. People actually look at specific patterns of the epigenome to determine your biological age. So someone can be chronologically 50 years old, but if you look at their epigenome, you'll perhaps find that biologically speaking, they are 58 years old, like 8 years older biologically than they are chronologically, which is associated with double the risk of dying. For each 8 years you're older biologically, you increase or double your risk of dying, according to one or a few specific epigenetic clocks. So epigenetic clocks can be very interesting to assess your general health by looking at the methylation patterns that are happening on your genome. So what we actually see, our DNA is methylated at a lot of different places. So methyl groups are small molecules that are put onto the DNA. And if a large swath of DNA is covered by methyl groups, the gene is deactivated. So it makes sense. If you cover a gene with methyl groups, or you cover the promoter of the gene with methyl groups, it's silenced or deactivated. So you can look at these patterns of methyl groups everywhere at thousands of locations on the DNA that is associated with lifespan or mortality risk or accelerated or deaccelerated aging. So these are epigenetic clocks. There are multiple epigenetic clocks developed, and they are becoming more and more accurate. And that's a great way to assess your biological age, because currently, if you go to your medical doctor to get a health checkup, and if you want to know how healthy are you really, there is not that much to go by, unfortunately. Your doctor can measure your weight, can do a blood test, and according to a lot of people, their blood test is normal, but still they can be unhealthy. So we definitely need much better assessments, holistic assessments of our health, and epigenetic clocks is one example, but currently scientists are also developing other kinds of clocks. For example, microbiome clocks that look at specific patterns of your microbiome, the bacteria in your gut, to determine your age. There are companies that are looking at ribosomal clocks or metabolic clocks or proteomic clocks. So there are many other different clocks in development. So I think probably the best epigenetic or the best aging clock will be a clock that is a mixture that uses different clocks like epigenetic clocks, microbiome clocks, metabolomic clocks, proteomic clocks, and so on. But it's a very interesting field, definitely. And it's very new, but there is a lot of promise there to much better assess your health and your risk of dying than current technologies.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
In regards to aging, I had some questions there. Again, why do we age? Does anyone have any idea? Do we have a further understanding of the process?
Yeah, the last 10 years, we learned more about aging than the 10,000 or 1,000 years before that. So I think the field is moving very rapidly, especially the last 10, 20 years. We have seen interesting breakthroughs and a much better understanding of why we age. We don't know or we don't understand everything yet and are actually far from it, but still we learned a lot about aging. And there is the classical paper, 9 Hallmarks of Aging, that describes 9 reasons or important reasons why we age. There are probably a few more, but we are getting a much better understanding of why we age. And perhaps very quickly, some reasons why we age is, like I mentioned before, epigenetic dysregulation. So when we get older, more and more our epigenome becomes dysregulated. So some genes are switched on that should be switched off and vice versa. Second reason why we age is DNA damage. A third reason is mitochondrial dysfunction. So the mitochondria are the power plants of our cells. They create energy for our cells, and they're very important, of course. And when we get older, the mitochondria become more and more dysfunctional. Another reason why we age is the accumulation of senescent cells in our tissues. So senescent cells are cells that are too damaged and they stop dividing, but they don't die and they stick around. They are called zombie cells. And they secrete harmful substances that damage neighboring cells. So they secrete, for example, growth factors or pro-inflammatory factors or substances that break down the extracellular matrix, which is the intercellular glue that makes cells stick together and builds up our tissues and organs. So senescent cells is also a reason why we age. You have telomere shortening, which plays more a role in fast dividing cells. Another reason why we age is accumulation of proteins inside and outside of our cells. So, for example, it happens in a lot of aging-related diseases like Alzheimer's disease. There we see an accumulation of protein inside brain cells and outside of brain cells until the brain cells get suffocated by the protein gook that piles up, that builds up, and die off. That's one of the reasons why we get Alzheimer's disease and many other aging-related diseases. So protein accumulation is also another reason why we age. And then we have, for example, transcriptomic dysregulation. So the transcriptome is a little bit like the epigenome. So it determines also, let's say, how active specific genes are and how well they are translated and transcribed into protein. So these are a few reasons why we age. If you would ask me what's the most important one, well, some scientists believe that epigenetic dysregulation is a very important one because, as I mentioned before, we see that if you epigenetically reprogram mice, they become younger again, and a lot of aging damage is repaired through epigenetic reprogramming. So in these mice, or these epigenetically reprogrammed cells, we see that a lot of aging-related damage is undone, like mitochondrial function improves, protein accumulation is much better or much less, DNA damage is repaired. So it seems that some hallmarks of aging are more important than others. And epigenetic reprogramming is one reason to believe that.
So it sounds like, all living creatures are able to adapt to their environment, but over time, this adaptation, I guess, goes wrong, and they build up, errors and problems in their epigenetics and transcriptomics and DNA, et cetera. And then it kind of keeps going and I guess puts someone on the path to aging and eventually death. That's what it sounds like. But what is your overall feeling when you look at the process of what happens as to the why? Why do you think this is happening overall? People are aging.
Yeah, that's a great question. Why does aging exist? So first of all, if we look at nature, or let me put it differently, a lot of people think that aging exists because it's inevitable. It's the wear and tear of cells functioning, and it just goes down. But it's not that simple, because we see in nature there are specific organisms that don't seem to age. They are immortal in a biological sense. You have like specific polyps that don't really seem to age. You have some jellyfish like Turritopsis dohrnii that can even rejuvenate itself, so it can become younger, especially when it's stressed, which is interesting because when we get stressed, we get older faster and we get gray hair and whatnot. So, and we also see huge differences between different species. You have like whales that can live up to 200 years. There are some sharks that can live up to 400 to 500 years. And even if you look at the rodents, you have mice, they only live for 2 years. And then you have naked mole rats, which can live up to 30 years. So much longer than other rodents. So we see that actually nature can determine the rate of aging really significantly. Take, for example, an aging-related disease like cancer. Some people say, cancer, it's inevitable. It's because damage of cells, DNA damage, and so on. Actually, it's much more complex. Cancer is not just caused by DNA damage, but also epigenetic damage and so on. But that's another discussion. But people say, look at cancer. That's a nice example of a very complex process that is the consequence of damage that accumulates during lifetime. But if you look at mice, they get cancer after around 2 years. If you look at humans, they get cancer after 70 or 80 years. So if you look at the graph that depicts your risk of cancer according to your age, the graphs of mice and humans look just the same. And the older you get, the more risk of cancer. But only the timeline is different. So mice get already cancer after 1-2 years. We get it after 70 years. And then you have bowhead whales that get cancer after 200 years. So this is a nice example that nature can slow down your risk of aging and aging-related diseases 30-fold or even 100-fold and so on. And that's a nice example of how nature can very easily determine the rate of aging significantly. So it's not that aging is caused by just thermodynamics and so on, because nature can really repair and undo and determine the rates of aging significantly in different organisms. And it all depends on evolutionary pressure. So why do mice have only a lifespan of about 2 years and some bowhead whales can live 200 years? And that's a 100-fold difference. Well, that's very simple, because if you are an organism and you grow up in an environment that's very hostile, then it pays off to not invest into a long lifespan, because you will be eaten or you will die of cold or starvation very quickly. So there is no use for a mouse to become 200 years old if you know that 90% of mice die before age of 1 year. So that's why evolution, invests more into reproduction and so on, instead of trying to maintain the body for decades or even centuries. So it's not that nature cannot do it. It can solve aging very easily and postpone aging a lot, but it doesn't feel the need for it for specific organisms that live very short. And that also explains why turtles live very long or bowhead whales live very long, because they die much less of external causes of death. So a turtle has a shield, So it means natural predators cannot eat or die or kill the turtle very quickly. So every mutation that happened in these forebears of these turtles that extended lifespan was useful because these turtles could actually live or stick around for that long because they had very little natural predators. Same for bowhead whales. They are whales, they're very big, so they don't have a lot of natural predators. Same for birds. A lot of birds can become very old, like you have like albatrosses or parrots that can live up to 80 years. Well, they have wings, so they can fly away from threats, and they can find food much easier. So that's why we have this natural selection towards much longer lifespan, and that's often related to how well you can stick around in nature and how well you're protected against external causes of death, which is predation or infectious diseases or other problems.
How would you describe DNA damage in detail? How does it happen? And then same for epigenetic damage. Like, what does that process look like step by step?
Yeah, there are many reasons or causes of DNA damage. So you have DNA damage like you create dimers between specific DNA base pairs. You have also DNA damage where the base pair is a little bit chemically altered. And you have also more significant DNA damage where you have DNA strand breaks, like double strand breaks, which happen about 40 double strand breaks happen, or 20 to 40 double strand breaks in each of our cells. And you have more like smaller damage to, you have 10,000 small damaging cells in each of our cells every day. So our DNA gets damaged a lot, but luckily most of this DNA damage is repaired quite well, not perfectly. And that's one of the reasons why we age. But long-lived species, they can repair their DNA damage much faster or better, or they just kill off cells that are that accumulate too much DNA damage very quickly. So we see in some whales or other species like naked morads that they probably can just kill off their damaged cells quickly before they can cause cancer or become senescent cells, which then linger on and damage surrounding cells and so on.
Okay, so what are there particular projects that you're funding right now that are of great interest to you? Or what are you working on that you feel holds the most promise for unlocking anti-aging or helping with a particular disease?
Yeah, well, there are a lot of interesting projects. For the Longevity Vision Fund, we are investing in novel kinds of gene editing, like I mentioned, the transposon technology, which is very interesting. We're also investing in novel carriers to bring the DNA editing machinery into cells. As you know, you need to insert that DNA editing machinery in a vehicle to get them injected into the body, and that vehicle delivers the CRISPR-Cas9 protein, for example, into the cells. But the problem is currently a lot of viral vectors are used, but they have some shortcomings. So you put the DNA machinery into viral vectors, and these viral vectors, they are like little mini viruses, and they infect cells and then inject the DNA or RNA into cells, and that's translated into a protein. But the viral vectors have some shortcomings, like you have pre-existing immunity against some viral vectors because they look a lot like viruses that cause common cold, or they cause too much of a strong immune reaction. So we are looking into novel carriers, and classic novel carriers or current ones that are in development are LNPs, lipid nanoparticles. But there are more interesting carriers in that regard, like exosomes and so on. There's also something we are looking into quite significantly. We also look into AI for drug discovery, especially to discover novel drugs to treat aging. And also, I strongly believe, because I talked a lot about biotech, but I also strongly believe in nutrition and food supplements to impact aging, because the biotech will probably only available to treat specific diseases, because aging is not an official disease indication according to the FDA, which is very regrettable because most diseases are actually caused by aging, but you cannot officially treat aging as a disease according to the FDA and according to most other countries. So there I see supplements to slow down aging also as very interesting, because there are a lot of specific substances in nature that have shown to extend lifespan in multiple organisms, that have been associated with reduced mortality in humans, and that also have a lot of very promising and interesting data, but that are not being used because they cannot be patented. And that's very regrettable, because there are actually very interesting molecules in that regard, like fisetin, that are shown to extend lifespan in multiple species or alpha-ketoglutarate, which also could slow down aging and has extended lifespan in mice and other species, and is associated with improved health in humans. And even glucosamine, which is often used to treat specific joint problems. It's a supplement widely available, but little people or few people know that glucosamine is also associated with reduced mortality in humans and also with reduced heart disease in humans. So they have done studies looking at many supplements to see whether they can extend lifespan or associated with longer lifespans or reduced mortality in humans. And as expected, most of the studies didn't find, according to these studies, most supplements did not really extend lifespan, but only a few did, and one of them was glucosamine. So just saying, there are a lot of interesting substances out there that can also be used to slow down aging. And that's why I created NOVOS, which is a nutraceutical company using science-based substances to slow down the aging process. So I think there is also a lot of promise in that area too.
Excellent. Well, Kris, we're just about out of time. What's a good way for people to follow up? You just mentioned a company that you created that creates nutraceuticals. So how can people find out more about that? And then in general, your work, where can they go to learn more?
Yeah, so, well, people can find out more about NOVOS by just going at the website, novoslabs.com. That website also wants to be a longevity platform. So there you can find a lot of information for free to learn how to extend lifespan. So what's the best longevity diet, which foods can slow down aging, which other supplements are very interesting to take, and so on. So that's on novoslabs.com. You can also find much more about aging and longevity in my book. I have written a couple of books, but my latest book is called The Longevity Code. And there I explain novel technologies to extend lifespan, but also things we can do now to live longer, like which foods or diets are best for longevity. So that's also something where people can find out more. And they can follow me on my Instagram account, where I post now. I will post more stuff there about longevity. So these are a few examples where people can go to if they want to learn more about aging and longevity.
Yeah, last item, since you study anti-aging or longevity, I have to tell you my famous joke is, you know what they say about studying aging, don't you? And you say, I don't know. It never gets old.
Yes, definitely.
Yeah.
I agree with that. We have been looking for ways to slow down aging for thousands of years. But now I think we are a bit at a watershed moment, because we have all this fascinating new biotech to actually really start to make a difference in slowing down aging. And we have seen all kinds of fascinating studies that's showing that it's possible not just to slow down, but actually reverse aging. And we have never been able to, never before we have had these interesting tools and knowledge to really start making a dent in the aging process. So it will be a fascinating few years and decades ahead.
Excellent. Well, Kris, thank you so much for coming on the podcast. I appreciate it.
My pleasure. Thank you for the great questions.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.